Good morning, everyone. My name is Tika, and I'll be presenting today on the Nemesis Star hypothesis. I'll be giving you all some information on the history and development of the hypothesis, and my partner Dhruv will be talking about evidence both for and against the star, as well as continued efforts to locate the star. So, as most of you know, a largely accepted hypothesis for the extinction of dinosaurs that took place about 65 million years ago is the impact of a large comet, as to say, a comet that's greater than 10 kilometers in diameter. Well, more or less well-known studies are ones that have been done by a pair of scientists, Rob and Sepkoski, who used their knowledge of the fossil record of marine vertebrates, invertebrates, and protozoans to postulate that the mass extinction that happened 65 million years ago was not an isolated event, but rather one event in a cycle of several mass extinctions that occur in 26 million year cycles. Although Rob and Sepkoski could not identify a cause for the suggested periodicity, they suggested it could be a non-terrestrial connection. In order to account for the regular timing of the mass extinctions, the Nemesis theory was devised by Richard Mueller. In this theory, a companion star orbiting the Sun from approximately 3 light years away perturbs the Oort comet cloud every 26 million years, causing comet showers in the inner solar system. Now, this may seem like an absurd claim, but think about it this way. In the extreme vastness of space, Earth is such a small target. How would it be possible to hit such a small target precisely every 26 years? Work that's been done by Alvarez has shown that at least 2 extinctions, the one that killed the dinosaurs 65 million years ago, as well as the one that killed many land mammals at the end of the Eocene 3,500 million years ago, were caused by asteroid impacts, and Mueller used calculations along with Kepler's laws and the statistical analyses done by Rob and Sepkoski to confirm that the 26 million year cycle trend was possible. Furthermore, evidences in cosmic ray exposure and iridium content allow for the plausibility of the Nemesis Star hypothesis. For instance, meteorites created by comets have been shown through cosmic ray exposure to have fallen to Earth at approximately the same time as the last 3 extinctions. This is determined by measuring isotopes such as neon-21 in meteorite samples, which can give information on the amount of time a meteorite has spent orbiting the solar system. Meteorites that impact comets have indications of a high iron content from asteroid cores or planets that have been blasted by collision with comets. A correlation of these high iron content meteorites have been found with the occurrences of mass extinctions, giving plausibility to the Nemesis hypothesis. In addition, the discovery of high concentrations of iridium, which is usually only found in extraterrestrial objects, such as comets, provides evidence for the Nemesis theory. The limestone found between the KT boundary contains a layer of clay that is 600 times richer in iridium than that of the surrounding limestone. Furthermore, this iridium layer contains rhenium with a half-life similar to the rhenium in the Earth, suggesting the extraterrestrial body would have to be born at the same time as the Sun. A proposed companion star would have had to have been born along with the Sun as well, allowing for plausibility for the Nemesis Star hypothesis. Now, I'd like to turn it over to my partner Dhruv, who will be giving you some information on evidence that's been found both for and against the Nemesis Star hypothesis, as well as continued efforts to locate the star. Thank you.
Hello everyone, my name is Dhruv, and like Tika said, I'll be continuing the presentation on the Nemesis Star hypothesis with evidence both for and against it, as well as continued efforts to locate the star. One particular line of reasoning that leads to the existence of Nemesis is that about 60 to 70% of all stars in the galaxy are in a binary star system. Therefore, it is not unlikely that the Sun has a companion star orbiting around the center of our solar system. Furthermore, astronomers have identified a large planet-sized object orbiting the Sun in an extremely long and elliptical orbit. This planetoid, also known as Sedna, is orbiting in such an area where no planetary objects were expected to be found. Michael Brown of Caltech said that Sedna should not be where it is, and that its very elliptical orbit is highly unusual. After studying the orbit of Sedna, scientists concluded that there is another massive object altering its orbit around the Sun to be more elliptical. The object is also said to have pulled Sedna farther and further away from the orbits of the rest of the planets and into a very empty region of our solar system. Based on this, some believe that the massive object responsible for Sedna's abnormal orbit is disrupting the orbits of comets and sending them towards the inner solar system. Because of this, some people believe that this massive object is the Nemesis Star, which would be large enough to cause the irregularities in the orbit of Sedna. However, some scientists are still skeptical to the existence of the Nemesis Star. An orbit that is as long as Mueller has suggested would be too unstable and would not have lasted long enough to cause the periodic mass extinctions. However, Mueller responds by saying for the past billion years, Nemesis orbit has been causing this periodicity, but in the next billion years, will slowly start to be thrown out of orbit and no longer cause this periodicity. Other scientists, such as Kirkpatrick and Wright, believe that the Nemesis is not flinging comets towards Earth and that it does not lie outside the Oort cloud. Instead, they say that it is within the Oort cloud and is therefore in a more stable orbit than the one proposed by Mueller. Furthermore, some argue that the periodicity of mass extinctions is not precise, varying by a couple million years. However, Mueller suggests that this is a result of passing objects causing a deviation in Nemesis' orbit, which in turn causes a change of a few million years over long periods of time. Other scientists have even said that it is not a star that is affecting the orbit of comets, but rather a planet. Tyche, a hypothetical gas giant located in the Oort cloud, could be responsible for periodically sending comets into the inner solar system. If Tyche does not exist, its presence will undermine the emphasis for a Nemesis star, since it can both alter the orbits of comets and is large enough to cause the current orbit of Senna. Finally, if evidence arises that the other mass extinctions were not related to impacts from space, then the Nemesis star hypothesis loses. Through the years, there have been many attempts to identify the mysterious Nemesis star, but none have been successful. If Nemesis does exist, it is hypothesized to be either a red dwarf or a brown dwarf star. If Nemesis is a red dwarf star, then evidence of its presence would already be collected in catalogs. However, to confirm its presence, its parallax need to be measured, but due to its low proper motion, its parallax will be difficult to detect. To aid in the search for Nemesis, scientists are using the Wide Field Infrared Survey Explorer, also known as WISE, telescope to map out the solar system. WISE scans the universe in an infrared spectrum looking for heat sources. This is useful because it can search a much larger portion of the sky. WISE was initially meant to look for brown dwarf stars, but even if Nemesis is a red dwarf, it is expected to find it. With the help of new technologies such as WISE, scientists are hoping to find further evidence for the existence of the Nemesis star in the future. Thank you for listening, and have a good day.